I am Abraham and I am here to present my new research topic, testing of a new lubricant in metal forming. So before explaining my research topic, I would like to introduce myself. So as I said earlier, I am Abraham and I am studying in University of Colombo. And this is my first year of doing my Masters in Mechanical Engineering in UOW. So let's start the research. So once again, my topic is testing of a new lubricant in metal forming. For understanding this topic, we need to know what are these keywords in this topic. The keywords in this topic are lubricant and metal forming. So as an introduction, I would like you to know what is metal forming and what is lubricant. Metal forming can be described as a process by which a workpiece is reshaped without adding or removing any material from it. That means that the mass remains unchanged before and after the process. There are various type of metal forming process in our industries. This includes rolling, stretching, drawing and many other operations. When it comes to lubricant, for performing a metal forming operation without removal of material, a lubricant is inevitable. So lubricant can be defined as it's a substance which is added between two surfaces in order to reduce friction or wear rate. Lubricants can be of many types. It can be solid, it can be liquid, it can be gas or even a dispersion. The various lubricants that are used in our industries include graphite, molybdenum disulfide, oleic acid and polytetrafluoroethylene. So I hope that you got an overview of my topic. So I am moving forward to discuss the importance of my topic. Why we need a new lubricant or what are the problems with the existing lubricants? So I have shortlisted all the problems faced by conventional lubricants, and the first problem was the presence of additives such as chlorine, sulfur and phosphorus, and these chemicals can cause a serious stress to environment. And the second problem was the efficiency problem, because the efficiency produced by this lubricant was not up to the mark, and it involves high rate of wear and high material transfer. And finally, it needs to be replaced after every cycles. So by keeping all these problems in your mind, in order to overcome these problems, I would like to introduce a new lubricant called boric acid. As it seems in the figure, boric acid is a simple compound. It is a layered structure comprised of one boron atom, 3 oxygen atoms and 3 hydrogen atoms. However, the bonding behavior of boric acid is a little bit strange because it involves two types of bonding. Within the layers, the atoms are bonded with hydrogen bonding, while between the layers, the atoms are bonded with weak van der Waals forces of attraction. This dual forces of attraction or dual bonding behavior provides a lubricant mechanism for this structure. Due to weak van der Waals forces, each layer of boric acid slides relative to one another, and it reduces friction and enhances the smooth flow of surfaces. And on the other hand, the strong hydrogen atoms or strong hydrogen bonds resist the normal forces acting on the lubricant, and thus it prevents the breaking down of lubricant film. So theoretically, it makes an efficient lubricant structure. So in order to study its practical application or practical behavior as a lubricant, I have studied experiments conducted in the journal Dry Lubricant Films for Aluminum Forming. It was published in the year 2000. In this journal, it was clearly described that for every operations, boric acid has a low coefficient of friction initially. But after that, the boric acid film breaks down, and then the friction coefficient increases to 0.4. That means it increases from 0.04 to 0.6. The author was able to explain the reason for this happening, and he explained that this is due to the dehydrating nature of boric acid. That means that boric acid gets dehydrated on high loading and high temperature to boric oxide. Boric oxide is a less lubricous form and it does not exhibit much lubrication characteristics. And one more important observation in this experience was the boric acid, when it was mixed with a mineral oil, the dehydrating nature was eliminated. So I studied so many boric acid mineral oil combination and I came across boric acid canola oil mixture. When I studied the properties of boric acid canola oil mixture, I was able to understand that it was a good lubricant because it has got many advantages, such as it has no sludge generation, it was environmentally safe, and there was no need of replenishment as well. However, it has also got some disadvantages because the efficiency was less when compared with other transmissional fluids, and moreover it was flammable, so it cannot be used in high extreme temperatures. So by collecting all this information and knowing all the gaps in the previous research, I formulated my research question. So this is my research question: which biodegradable mineral oil can be combined with boric acid to derive one eco-friendly lubricant in metal forming process? So I researched I started designing my research. My research design was an experimental design which involved multiple experiments. So it involves 3 steps. The first one was preparation of different mineral oil combinations. The second one was performing ball and disc experiment, and the third one was testing and comparison of successful lubricant with conventional lubricants. In the first step, that was the mineral oil boric acid combination preparations, I collected most of the details regarding mineral oils. Then I filtered out a few mineral oils and I mixed boric acid with different particle size and different combination ratio to evolve different mineral oil boric acid combinations. And after preparing this mineral oil boric acid combination, I performed ball and disc experiment. In this experiment, the disc was coated with different lubricants, and a ball is allowed to slide over the disc. And during this operation, the friction coefficient for every lubricant was noted, and the lubricant which has got the minimum coefficient of friction is proceeded for the next experiment. The next test or the next step involves the testing and comparison of lubricant. This involved many operations involving the selected lubricant mineral oil combination with operations such as cold strip rolling, ring forging, stretching and deep rowing, along with conventionally used lubricants such as Teflon, Shell LS68, oleic acid, boric acid, KTLN60 and Molycot. So like the second step, here also the coefficient of friction were noted. If the selected lubrication combination has come up with the lowest or the minimum coefficient of friction, we can say that the derivation or the formulation of a new lubricant is successful. And if in other cases, further research has to be conducted in order to develop a new lubricant for the metal forming processes. So this was my research design. My research design has got so many advantages, such as it involves multiple experiments. So it can be said that the results obtained from these experiments are certainly true. And moreover, the particle size and combination ratio, which were failed to explain in the previous research, were clearly described in this research. And in this research, various combinations other than boric canola oil mixture were also tested. However, it also got some disadvantages. The combustible nature of mineral oils were not tested in this research, and since it involves multiple experiments, the cost of research was also high. Thank you.